Okay, this is lesson 4.4a, part 2. Hopefully at this point you've watched 4.4a, part 1, graphing using transformations, and you've watched 4.4b, where we graphed using the step pattern. By now, hopefully you figured out which way you like graphing, whether by transformations or the step pattern. This video is not about graphing. This video is about using that equation, that vertex form of an equation that I'll write at the top here. Vertex form y equals a x minus h squared plus k. Using that equation. Oh, we couldn't even see it. Using that equation. And it's really important that we be able to use that equation. Uh-oh, hold on. Okay, this is part 2 of lesson 4.4a, and this is where we're going to work with vertex form of a quadratic. And I've written it here at the top. Vertex form of a quadratic is that y equals a x minus h squared plus k. It's also where we can find transformations, shifting left right, shifting up down, stretching or compressing. And we've now identified that the h and the k represent the vertex. The first thing we're going to do with vertex form is, instead of actually graph from an equation, we're going to work backwards. I'm going to show you how we can get the equation from a graph. And here's how you do it. First thing you do is you identify the vertex. Our vertex is right here, and that looks like it is -1 for x and 8 for y. And what do we know about that? Well, we know that the h is the x of the vertex, and the k is the y of the vertex. So that's why we start by identifying the vertex first, because of the three things we have to fill in, the a, the h, and the k, we can knock two of them off right away, the h and the k. So let's start filling in this equation. I'm going to rewrite it first. X minus h squared plus k. And now we're going to fill in what we know. We don't know y. We don't know a yet. Still don't know x. But we do know h. H is -1. If we're going to subtract -1, that would be like adding 1. And that's why that sign's the opposite in the bracket. Remember how when we find h, we actually take the opposite sign out of the bracket, like -1 corresponds with an x plus 1 squared in a bracket, opposite sign, because it's shifted the opposite direction. Plus 1's a shift left 1, because our vertex is on the left side. And k stays the same, plus 8. So let's quickly run those down in colors again. We've got our h is -1, and our k is 8. All right. Now we got to figure out a. A is a little bit trickier. To figure out a, now we use a point. So first things first, over here I'll write some steps. Steps. We write the equation. We fill in vertex, because the vertexes are h and k. And then step 3, identify another point. So we got to find another point, not the vertex. So I'm going to pick the y-intercept, because I think that one's a pretty easy one to read. 0, 6. Step 4, plug in point, because a point is an x, y. And if we replace the x and y, we'll only have one thing we don't know. There's our point. we've got an x and a y. Let's fill that in. 6 for y, 0 for x, and now we only have one unknown, a. So our last step, solve for a. We want to find a. How do we do that? Well, we got to do a little bit of rearranging. Let's simplify this bracket thing here. We've got 0 plus 1 is 1, and then we're going to square it, and then we're going to add 8. Well, this 8 we could move to the other side and subtract. 6 minus 8. And 1 squared is just 1. 6 minus 8 is negative 2, and a times 1 is just a. So we end up with negative 2 for a. Now, if in the bracket, say we had a 2, 2 squared is 4. 4 times a would be 4a. To get rid of the 4, we'd have to divide it away. We didn't have to do that because we only ended up with a 1 here, but just keep that in mind. Now that we know a, we can finally rewrite the equation. And your final equation should have a, h, and k filled in. So we've got y equals a, negative 2, x minus h, subtract negative 1, is plus 1, squared, plus 8. Basically, we're going all the way back to here, and we're just filling in the a. And there's our final equation. So this example is how to write an equation from a graph. And you can guarantee that this will be on your unit test. Example 3 is an application question. And we've done an application question, but our application question was using standard form. It was that y equals ax squared plus bx plus c form of an equation. This time, we're going to do a similar question, but we're going to do it in vertex form. Vertex form tells us a little bit of different information. So let's take a look at how a vertex form application question works. A ball is hit into the air. Its height in meters after t seconds. So height is negative 5 times t minus 4 squared plus 120. In which direction does the parabola open? Well, our parabola opens down. It opens down like this. How do we know? Well, because a is negative. And if we remember, negative people frown, so our parabola opens down. B says, what are the coordinates of our vertex? Well, our vertex, because this is in vertex form, is 4, 120. Now, a vertex has two parts, an x and a y part. In this equation, we don't have an x and a y. We have t's and h's. So t and h. When it says, what does this vertex represent? Well, it represents, since our parabola opens down, the vertex would be right here, this represents the maximum height. Which of these numbers is the height? Well, it would be the 120, because it's the y part, and the y part is the height. So we would say something like the maximum height is 120 meters. And that happens after 4 seconds. 4 seconds after the ball's hit. That kind of makes sense. Ball's on the ground, it gets hit up into the air, and it lands. The vertex demonstrates the maximum. The maximum is 120 after 4 seconds. From what height was the ball hit? Well, that's an interesting question. To answer this question, we have to know when the ball was hit. The ball's hit, and then we start tracking it. So the ball's hit at time 0. So if we want to know the height when the ball is hit, we can use our equation. H is -5 t minus 4 plus 120. Well, we know t is 0, so we can just plug it in. 0 minus 4 squared plus 120. And now we just have to solve it. Solve it using bed mass or a calculator. If we're going to do bed mass, we've got 0 minus 4 is -4. -4 squared is 16. -5 times 16 is, I'm going to come over here, -80 plus 120. -80 plus 120 is 40. So therefore, the ball is hit from a height of 40 meters. Wow, that's quite tall. It must have been hit off of an object, or maybe off of a cliff or something like that, and then it went up into the air, and then it, wow, it wouldn't land. It would just meet the, well, I guess it would have to land at some point. Gravity. D says, what's the height at 3 seconds? Well, we would do that in a very similar manner. Height at 3 seconds, that's time is 3. We just use the equation again. -5, 3 for time this time. Using the same equation we did right here, but instead of 0, we put in 3. 3 minus 4 is -1, and -1 squared is 1. -5 times 1 is -5, plus 120 equals 115. So we could say something like, after 3 seconds, the ball is 115 meters, meters up. E says, at what other time is the ball the same height as in D? Well, this is an interesting question. Let's take a look. We could probably draw what this looks like, and that might help us figure it out. Well, let's take a look. We've got our heights, and we've got our times. We know a couple heights and times. We know at time 0, we're 40 meters. We know the vertex happens at 4 seconds, and that height is 120 meters. We know at 3 seconds, so 1, 2, 3. We just found that we have 115. So we know our graph is going to look something like this. Well, the nice thing is we can use the idea of symmetry to figure out the answer to this question. Well, the answer to this question is that if we're symmetrical around the vertex, then if 1 second before the vertex we were at 115, 1 second after we'll be back at 115 because of symmetry. So that would be 5 seconds. In fact, if it took us 4 seconds to go from 40 to the vertex, it would take us 4 more seconds to get back down to 40. And that's not what the question's asking, but it's how you can use symmetry to fill in your picture of the parabola. And now, having only known 3 points originally, we use symmetry to come up with 2 more. And that second point, this one right here, helped us answer the question. T equals 5 would be the answer. Now there is a way to figure this out algebraically. All I really need you to be able to do is figure it out by using symmetry. But if you wanted to figure it out algebraically, you could use the equation. Our equation says -5 t minus 4 plus 8. Not plus 8, plus 120. Well, they gave us the height. The height they said was 115. And we want to solve for time. Well, we just solve for it. We isolate for t. And how we isolate for t is we rearrange. We bring the 120 to the other side. (115 minus 120 is -5. We divide both sides by -5 to get rid of the -5. -5 divided by -5 is 1. Now we just have t minus 4 squared. To get rid of the squared, we square root. To get rid of the squared, we square root. We're just left with t minus 4. The square root of 1 is 1. But it's also -1. Because 1 times 1 is 1, and -1 times -1 is also 1. And this square rooting is how we end up with two different answers. Because watch, keep the t where it is, bring the 4 to the other side, we end up with 4 plus minus 1. Well, what's that mean? Well, that means our time is both 4 plus 1 and 4 minus 1. 4 plus 1 is 5. There's one time. And 4 minus 1 is 3. There's your other time. This is how the math gives you your two answers. This is how the graph gives you your two answers. For the purposes of our knowledge and application, I need you to understand the graph. For the purpose of a thinking question, it might be useful to understand why the algebra gives you two answers. This is definitely going to be useful next year when you continue to explore quadratics. And that's it for part 2 of lesson 4.4a. Thanks for watching, and I'll see you for our last lesson, 4.5.